We have a nice presentation for you. In case any of you don't know, this is Dr. Alex Hall, veterinarian for fish, coral, dogs, and cats. And has worked with us, how long has it been now? A few months.
About 8 months, 9 months.
Yeah. In the event, I want to start out by answering this question: what is Polo Reef? And it was my attempt to separate financially and give back to the hobby via educational videos, philanthropy, bringing kids in from schools, as well as doing podcasts, trying to make products better, and really trying to push the hobby forward, including various experiments that we're doing. Again, we have kids and schools all the time. We visit Florida right here. Those Florida corals being saved in Noah's Ark fashion. And help these guys out quite a bit. This is West Palm Beach. And schools, and the schools, all 40 or 50 people get on buses and come to my house. They give me a presentation, and we give them a presentation. And we help some local schools that have marine science programs locally and also in places like Iowa. We have guests over our house that win things from raffles to, questions on our group. And now we have this Polo education, Polo University, where Doc and I give best practices for sick fish and doing different things. So we're doing all these videos. We are developing new approaches for fish and coral quarantine. We're doing some medicines now, mixing antibiotics for clams. We're doing some stuff on other problems with corals, conducting scientific studies with swabs and then hitting them with meds and then doing the swabs again, donating funds to coral restoration. I am trying to improve the products out there of lighting companies and our chemists like ESV here, who I've gotten to increase some trace elements in the salt for everybody. We're doing weekly ICP testing, and now we're starting to send genetic stuff to Aquabiomics to study diseases of fish, clams, etc., etc. And then I want to introduce you to the best investment so far that I have made in personnel. And the best way I can say this is this: no more guessing. And that means I don't need to figure out whether the fish has urinema or a bacterial infection. I just know. And I don't hit it with two different medications. I know I might until I get the result, by the way. That's the one difference between him and I. He likes to get the result and what the bacteria is sensitive to, and I want to save these fish and lean a direction first. But nevertheless, everything is basically under a scope, and we know what antibiotics it's resistant to, what it's sensitive to. Even if we can't save the coral, that one particular coral or clam, etc., we know once we see that species again, what it is resistant to and what it's sensitive to. So, doctor, You have taken care of my koi. He has given my koi several shots. Saved a few of my koi already. Treats them for flukes all the time. I trust you, flukes in the koi are way harder than flukes in marine fish. We're able to add fish to the tank now without adding medication, which for really medicated sensitive fish is a big deal. And really what we're using is scrape and gill biopsies. And they have to have, how many you want?
At least three.
At least 3 negatives before they go in the tank if we're gonna not medicate. And you know, there are certain fish like regal angelfish or Lenardi wrasses or fem wrasses or Yerpel tang. There are just fish you just don't want to medicate. And this has given at least me the confidence of not using the microwave oven. And so we put them in a coral system, not even in the quarantine system with the meds. We put them in a coral system, and he tests them and scrapes them, and as long as we're clean for 3-4 weeks in a row, pretty confident that fish is clean. And so it's actually saved fish from unnecessary stress. The purple queen's a great example. I think people hit them with copper, ruin their appetite, they don't eat. This time we went with no meds. I think we hit him with formalin twice. I'm not sure, one might have been an accident.
But going back to it, again, every single fish, every coral, everything is inspected coming in. Again, it's not just a quick check. You know, even a single acro frag, I'll spend 5-10 minutes on and dip it, look at it, change anything changing. Does the tissue look different? You know, in subsequent days, does that tissue changing? Is there any differences in polyp extension? Again, being really tedious in terms of, is there any change in the coral over a significant amount of time? I think a lot of times when we check coral, we get excited, you know, you take a quick look at it and you see nothing and you put it in your tank. And that's what we're trying to avoid, is by really examining each piece under the microscope, under a triocular scope, even with UV light, because again, some of the parasites are a lot easier to see with UV light. So we'll turn off all the lights in the lab. We'll use only the UV. And again, it makes them a little more identifiable. And again, is there eggs? Is there anything else that we're looking for? And again, we keep combing through until either A, you know, we deem that they're clean, or B, if we find a disease or we find a parasitic organism, we let it then sit in quarantine until A, you know, treatment is dissolved, or B, they're manually removed one by one in certain instances.
I mean, the drugs that we are using, we're going to get into this Polo lab. Let's start off 1 second. We're basically using your standard dips, antibiotics like chloramphenicol, and then chloramphenicol mixed with things. We're using the new metronidazole, which is tinidazole. We're using mibamycin for bugs. We're fooling around with fenbendazole, Prazi, all that stuff.
Yeah, no, again, it's instead of doing broad spectrum treatments, it's identifying what the problem is first and then treating subsequently, rather than going, oh, does this drug work based on, you know, a guess? It's like, oh, on a theoretical level, does this drug interact with that organism in a mechanism that's going to end up killing that organism? So again, it's not just dumping in, you know, milbemycin to try to treat acropora flatworms. Again, mechanistically, that's not one of the best choices. So again, it's working backwards from the mechanism, working through the pharmacology, and going, is this on a theoretical level able to kill the organism we're trying to treat? And then once we've gone, okay, theoretically it can work, experimentally, how can we put that into practice? You know, what's the level of drug concentration that's needed to kill that organism? What's the level of drug concentration that kills the organism that we're treating? So there's always a thin line. Again, a lot of the compounds we're using are toxic across the board, but is it the, you know, once we have an organism, we're trying to kill a specific organism at a certain level, but not kill its host, right? And that would be the coral.
And we're doing that with clams right now, and wild clams, and making dips that, and we swab the clams coming in, It comes back Vibrio, sensitive to blah, blah, blah. We add an antibiotic to the bath, and next thing you know, that Vibrio is gone, and another bacteria shows up.
Yeah, so in those instances, we have, again, and I always make it clear, is we're swabbing the external part of an organism, right? So if I swab my skin right now, it's going to come back with staph. That doesn't necessarily mean that that bacteria is causing the problem. This is where we're starting with what bacteria are even present and what populations are they present, and are they pathogenic, or are they commensal, or are they commensals that become pathogenic? So it's finding what organisms we're working with first before delving into which ones are actually causing the disease. With clams, it's a shelled organism. The tissue's quite hard to get to. So when we're swabbing the feet and swabbing the mantles, again, we're finding these bacteria, but it doesn't necessarily mean that they're pathogenic. But
No,
the species,
they could be dying from ozone or gas diseases. We're actually moving around the clams in different tanks and finding that the one where the oxygen saturation and gas levels are the highest are actually doing worse than the ones that are the lowest. We don't know if that's from the ozone or just straight up. We should all just have trickle filters, and Bob trickle filters. Yeah, that's the name of it. Strike a bell.
Bringing them back.
Yeah, and degas water more. We don't know. Okay, I don't know what we're going to try turning the ozone off and seeing whether the clams live better that way. We have also had some clams that we noticed ingested some dinos, osteo, and will poison the clam slowly. So clams are not the easiest, and we're working on it. Okay, the Polo Reef Lab used to look like this. And over we redid it completely, and now it looks like this, a real lab with, and that's the renditions, and now we have a doctor seat with a microscope, and then you can see Dr. Alex there. That's how he scrapes his fish.
So this is just
that.
looking at the external part. Again,
Right.
It's very hard to diagnose internal disease via scale scrape, but it gives us an idea of what bacteria are present. It's hard to identify the species of bacteria, but through gram staining,
Four quarantine tanks in the lab, 2 sort of display tanks actually 3 display tanks in the lab, and then a clam tank right now, which will be eventually a cold water species tank. This is all our holding tanks in quarantine, and then when we're out of quarantine, we make these 60-gallon cubes. Go back there. Doc, why don't you tell them a little bit about?
Yeah, so this one we have a bunch of tilefish in currently, which is going to be one of our case reports for today. So we'll go through that entire case in detail. And how we treated
is it next? What's next?
the tilefish.
What's next? Yeah.
Yeah, so we have a case of tilefish.
I'm sitting down.
If we could play this video. Do we have this video? Yep. So we had these tilefish, again, presenting with all sort of lesions through the tails, through actually necrosis of the epidermal layers of the skin, as you can see here. So what we did...
I may have caused this, by the way. I want you to know I panicked. We had Amphius. Do not ever quarantine a fish that may need formalin from urinema. And smooth-skinned fish like tilefish that can't take formalin. Okay, that's a no-no. I panicked because I thought I saw urinema. We did see urinema on the Amphius, and hit formalin right away, forgetting about the tilefish. And the next thing we know, they woke up with blisters the size of, they were infected, and infected with?
So in this case, first we did a fine needle aspirate of the tissue. again, characterizing the tissue. When I swab the outside of a fish, again, it's always going to come back positive with something. But with a fine needle aspirate, again, we can see in the video in the bottom right at some point, take a little needle, stick it into the lesion, collect cells from that lesion. Inside the lesion should always be sterile. So any bacteria that I culture from inside, right there was the fine needle aspirate, any bacteria that's cultured from inside the fish is going to be pathogenic, right? So we have, in this instance, there was a Vibrio angeliticus infection, which is something that we quite commonly see. So they were started on 2 different medications. One, they were started on intramuscular florfenicol and consistent baths or long-term immersion of kanamycin. A lot of the times I don't like to mix bacteriostatic and bactericidal drugs. Bacteriostatic means it just stops bacterial replication. Does not kill bacteria, just stops replication. Bactericidal drugs are the ones that actually kill the bacteria. I tend not to like to mix bacteriostatic and bactericidal drugs because sometimes they can start to inhibit each other. But in this instance, we sent out for culture. It came back as the Vibrio angeliticus. The sensitivities were both to kanamycin and to florfenicol. In terms of bacteriostatic medications, you tend not to want to use those in fish that are critically ill because we need a functioning immune system to be able to clear the infection. So if they're critically ill, the immune system's not going to be functioning at a level that's going to end up saving the fish. So that's why we added in this bactericidal medication at the same time. And they don't necessarily inhibit each other, as the florfenicol binds to the ribosomal subunit that essentially reads the DNA, whereas the kanamycin is disrupting the reading of the mRNA, and it's how it interprets it and puts the amino acids into sequence. So they kind of complement each other. Essentially, the florfenicol prevents reading, whereas the kanamycin
Breaks it.
puts the wrong amino acid in. So if the florfenicol wasn't sensitive enough, or if the bacteria wasn't sensitive enough to the florfenicol, and it didn't stop the reading of the ribosome or the ribosomal subunits, the kanamycin then would interrupt that reading and put a different protein in. So it's essentially like a fail-safe mechanism. Again, I don't always recommend this unless we have sensitivities to both mechanisms and they're binding to different subunits, as the florfenicol binds to the 50S and the kanamycin binds to the 30S. So it's, again, we have some synergistic behavior between the two of them. That being said, when we have, when we're diagnosing disease, again, we start with physical examination. We see lesions, we see abnormal tissue, microscopy of the lesion. So again, a scale scrape. So we're scraping here. Again, we didn't see anything abnormal here. It was actually the bacteria that was underlying within the tissue. And we have bacterial culture, which is what was cultured from the tissues that were pulled out through the needle. And then we have the polymerase chain reactions, which is a more sensitive. Again, it's just looking for DNA. Again, it doesn't tell you that something's pathogenic. It just says that the DNA of X organism is there. So we have the different susceptibilities right here on this table. Back, 5-10 years ago, then we had a lot more susceptibility to a lot more drugs, right? But as a hobby and as the industries have been using more antibiotics, we're seeing resistances more and more and more common. And in this instance, really the only drugs that are susceptible to are chloramphenicol, gentamicin, neomycin, and kanamycin, whereas TMPS sulfa resistant.
Actually, I tried this first, and within 2-3 days, it was clear it was not working.
Mm-hmm.
And sure enough, then we get the thing back, and it's resistant. So I saw it happening, which was nothing.
So once we've treated these fish and they no longer have lesions, at what point do you risk putting them back into the system, right? The moment that we put these back into the 17,000-gallon system, it's extremely a high-risk scenario, right? We know they have disease. We're going to now introduce them. At what point do you say we're confident that they don't have disease? And we have a different tier list. First, scale scrape. Is there anything abnormal? Am I seeing any bacteria on microscopy? Is there any I know it's a gram-negative bacteria. I know Vibrio is gram-negative. Am I staining and seeing any gram-negative bacteria? Again, that's not the most sensitive, but something that we can do immediately in-house. Then we have bacterial culture, where we swab the fish. But again, if there's no active lesion, how do you know what bacteria is actually pathogenic? Again, you may still see that bacteria, but is it being pathogenic, or is now the fish cleared? So once we have step 2, check, we move on to bacterial PCR, and this is something that we're working with Aquabiomics and potentially University of Florida with in new gen sequencing, is there any DNA of the causal organism in the water column? Again, it may not be causing disease, but we knew it was there, and now if it's no longer there, then we know that we've successfully treated it, and the risk of them going back into general population is no longer there. So any positive result, if I see any gram-negative bacteria here, if I see any Vibrio here, or if any DNA on the Vibrio panel comes back, then we'd stop and reevaluate. And right now, we've passed these two steps, we're waiting for the bacterial PCR culture to come back and let us know that there is currently no Vibrio being shed in that tank. Again, there may be other species of Vibrio, and I'm not overly concerned with those because those are going to be in the environment. Is this particular species of Vibrio angelitica still being released into the water? In the aquabiomics and the way that PCR works is it doesn't really quantify the amount of bacterial load, but it can give us a proportion. So if I see, 1% of the bacteria in that solution that we sent in has Vibrio, I'm not going to be overly concerned because again, if these fish were shedding and still in an infectious state, I'd expect 50%, 30%, massive populations. Again, I can't get a direct count. I can just get a proportion based on the other bacteria in the tank.
So he's holding me back from putting fish in the tank. We have a log jam going on. You want to talk to him about the worst quarantine system that ever happened?
Yeah, so we had recently, did we get those pictures in or no? So recently we had...
Again, we had 5 systems, 4 of them are being used for rehoming. So we only have one system for treating fish. And we were trying to get a lot in from a lot of different places, a lot of different sources, and some dumb choices like putting chromis with Anthias. Chromis, you can use chloroquine phosphate if you get your uranema. Anthias, you can't. We just loaded the tank up with zillions of fishes for the 2,500. And Doc, what happened?
Yeah, so we had 2 different species of Vibrio.
Two or 3 of fish were dying a day, and they were dropping like flies.
Yeah. So we had 2 different species of Vibrio, 2 different subspecies of one Vibrio, Pseudomonas, Schwannella, monogenes, fluke, and uranema all in one system. So treating that became incredibly difficult because it's a step-by-step fashion. And not only are these diseases, working with each other, you have fluke that are disrupting the skin barrier. Now you have a disruption in the skin barrier. Now uranema, it's a lot easier for it to take hold. So once you have multiple diseases start stacking on each other, now you need multiple treatments and a lot more aggressive therapy. And a lot of times the fish can't handle that type of aggressive therapy when they're already in a disease state. If you have, fluke, uranema, and internal bacterial infection, you really start fighting a losing battle. So what we stress moving forward is really slow quarantine process. Again, all in, all out. But when we have only, a couple fish rather than several hundred at a time, especially if they're coming in from different, parts of the world. And the thing that we can't even discuss yet is, viral infections. And viral infections are extremely prevalent, but 1, finding them is extremely hard. 2, there is no treatment for viral infections. So now we take naive populations and we're mixing them together. We've got bacterial infections going back and forth. We've got viral infections going back and forth. We also had a single case, one of the Anthias had a fungal infection, which is incredibly rare in saltwater. And that Anthia is now currently down at UF being studied because, again, it's not something that we typically see. In freshwater, fungal infection is extremely common. Saltwater, it's very, very uncommon. So it was a very abnormal finding for us.
So we lost all the Pictillus Anthias from uranema. I'd say we lost a good amount of Scott's wrasses and other type of wrasses from combinations of uranema or bacterial infections. Yep. And we had about 25% of the tank survive because I just had to do something before Alex got his answer. Okay? I ran in and said, I'm changing this copper shit. It ain't working with uranema. And the Anthias were already dead on arrival, in my opinion. So we went with chloroquine phosphate and then added canna to the water. Heavy canna, chloroquine phosphate, and stopped the disease, pretty much.
Yeah, in an instance, and again, it becomes really difficult when you have so many fish in a population who, again, is there natural immunity? Is there other factors that are in
Yeah.
play? So
I don't know.
there was sensitivity to Cana across the Schwannella, but Vibrio, I think, is still an open topic for treatment. There definitely needs a lot of work in terms of protozoal diseases in fish. There's not a lot of consensuses on treating urinema and the difficulties that are associated with it, because often it's not just a single infection. You see your urinema, but it's not the only disease that's playing on, right? You have an open ulcer, that's going to have an infection regardless of bacteria.
Urinema is one big pain in the ass. From trying to save them once there's bruises and it's internally.
Yeah, so urinema presents in 3 ways. You can have an external infection, where you get that classic red banding lesion. In terms of those red banding lesions, everyone jumps to urinema, but roughly, and this is anecdotal, about 30% of those lesions are actually urinema. Often it's another bacterial infection that just presents like an ulceration. Every ulceration is not urinema, but I can tell you every ulceration is bacterial. Again, you can have urinema with bacterial infection, but anytime you have an open sore like that, you're going to have a bacterial component to it, not just a protozoal. And that's what I think a lot of times with the urinema is we're focusing on that protozoal interaction, but we don't know what bacterial component is going on.
That's why I throw it all in, Doc. Some antibiotics, a little chloroquine phosphates.
That's what we're trying to avoid, trying to be very specific with treatment, because we are seeing bacterial resistance on the rise. There's swabs that I've sent to the lab where they call me up and they go, oh, essentially we're culturing MRSA for you right now, and multi-drug resistant Staph aureus. There's every antibiotic we've run, it doesn't work. Do you want us to run a panel of antibiotics of last resort? And those are the antibiotics as an industry we shouldn't be touching. So those are the only treatments we have for people. So if we have one of these Pseudomonas infections that jumps into a person, and we've been using rifampin, we've been using vancomycin, there's no treatment for people. So once we cross that line in the lab saying, hey, there's nothing you can use, that's when things get really scary, because there's no treatment. And again, if someone in the lab is, has a cut, gets an infection, they may go to the hospital and start having very, very extensive trials, because there is no antibiotics that it is susceptible to. And as we go forward as a hobby and we're using more antibiotics and using them inappropriately in some instances, we're just selecting for resistance. With these short-term baths, someone says, oh, dump in X amount of X drug for an hour. That's not going to kill the bacteria, that's just going to kill the weak ones. So now let's say we have 100 bacterial particles, we put in amoxicillin, we killed 50 of them. Those 50 that are still left are going to grow back, and those are the ones that were resistant. So if we keep doing that, we're just going to select for bacterial infections that we can't treat. So we have to be using antibiotics in an appropriate and a sensitivity type manner. Otherwise, 10 years from now, 5 years from now, there's just going to be too many infections that it's impossible to treat, and we're making antibiotics as an industry. There's no new antibiotics coming out, right? They're all derivatives of old ones. There's nothing that's really been groundbreaking in probably 10 years. So the antibiotic resistance is evolving a lot faster than the pharmacological part of antibiotics, and developing them can move. So it's a big problem as we see more and more. And again, when we're using different antibiotics, even in combinations, if there's not susceptibility, now we're just exposing bacteria and we're killing the weak ones that would have been susceptible. There's a lot of different factors that goes into antibiotics and their choices and why we use them. And that's what
tell them about the time one and versus the.
So antibiotics, there's different ways that they work in, as we're talking about bacteriostatic, bactericidal, but there's also concentration dependent. Doesn't matter how long that the antibiotic is in contact with that bacteria, as long as it's over a certain threshold, we know that it's effective. Again, there's also time dependent. Is that, bacteria in contact with that drug for 12 hours? Is it in contact for an hour, right? And it's very dependent on the drug. And what I'm trying to avoid moving forward is really quick, short-term pulsatile antibiotics. That's not going to essentially clear an infection, right? If any of us or any animals have an infection, you're on antibiotics at least a week with consistent therapeutic doses. You don't get a pulsatile and then you wait till 3 days later and then you pulse again. Because again, now we're just selecting for that resistant bacteria. So we're creating resistance in front of our eyes. So when we use drugs now, like again with the clams, again, it's an everyday trying to keep at a therapeutic concentration. And it's a little bit harder when we have a reef than a human, right, or a dog. dog. You give them the drug goes in them, the body processes it and goes out. The same thing happens in a reef, but we have a little bit more like cross interactions between our filtration systems. But again, our filtration systems are no different than a kidney. Our filtration systems are no different than the liver. So we are constantly dropping in what's called mean inhibitory concentrations, but I think as a hobby, we need to get better at keeping those concentrations high, because the moment that those concentrations drop, now you get bacterial proliferation of those bacteria that were resistant to the first dose. So now we're just selecting. So we have to either A, increase the dose, B, increase the duration, or C, increase the frequency.
That's another way of saying we have no idea yet. But we're working on it. We'll get back to you. Okay, let me,
Go to the 17 or
yeah, this is a 17,000 gallon tank. There's no video here?
yes, but we got like less than 8 minutes to go.
Yeah, let's do it.
So
Watch this video.
the rest of there's no audio.
No audio. All right, so here's the lab. Tournament right here. You see all my skimmers and ozone. That's skimmer and sand filter. And then you start seeing what quarantine is. And we go to the sub-basement. That's where all the sumps are. And water storage, and that's how it was done. You can read this to yourself, but basically 1,600 amps in the house. And we had to write computer code that was bigger than most water plants. And we have several things. We rely on Skynet, but we don't trust Skynet, so we take 4 ORP probes and run them off the system to make sure they match the one on the Sky system, so we don't over-ozonize things. Same thing on the UV ballast. We want reads on what the computer thinks, and we want outside reads so the house don't melt. Here's the sumps. They go 8 feet underground, and it's already 40 feet down sub-basement, so you're about 50 feet below grade here. And we turn these bubbles up like this because we're getting a better oxygen in the atmosphere, and that lowered some gases. And then we built some of the UV sterilizers here. We did build some sand filter, which is not sand, it's glass beads. And I don't know where my stepson is going right now, but
So here we have our second case report, and this is...
that was a nice walkthrough.
This is a secondary case report of a koi with a polymicrobial infection. Polymicrobial meaning multiple infections going on at a single time. And this is why culture is super important, is we go, okay, we know we have an infection. Is there multiple organisms? Again, we're in a fluid that is full of bacteria. Again, more often than not, you're gonna have multiple bacterial infections. And when we have this, when we run susceptibility in cultures, it'll test each drug to each bacteria. So we know across the board that this drug will clear the infection. If we only, randomly picked a drug, we'd be able to kill, 1 or 2 of them. In this case, there was actually 3 different bacterial infections going on.
Under the jaw.
And how do we confirm this bacterial infection? Well, first, fine needle aspirate of these lesions, taking a needle, poking it in, collecting some of the cells, sending them out for cytologic reading first. So under microscopy, we can see highly cellular bacterial populations composed of coccobacilli and another species of bacilli. So we know that there's bacteria within the tissue. Again, these tissues should be sterile. There should be no bacteria within them. Any bacteria that's within the tissue itself is going to be of concern. And in this case, it was 3 different species of Aeromonas, which is known to be a pathogen in koi. The other reason why we did a fine needle aspirate in these cases is because neoplastic processes or cancerous processes are possible and more common than they're reported. So we wanted to make sure that there wasn't a cancerous process going on here. And if there was, to have a surgical procedure in removing these masses. The nice thing about this in red here, the red is the important bits, is that there was no inflammation, parasites, and or neoplastic cells identified, just these bacterial populations. So now we can rule then that it was only an abscessation due to bacterial infection rather than abscessation due to neoplastic or cancerous change. In this instance, we had fluorphenicol as a antimicrobial. Again, the fish wasn't in critical condition, so using a bacteriostatic medication is okay in these instances, and it was the only medication that it was acceptable across the board. And again, I don't like mixing antibiotics, so I don't have to. So fluorophenocal was the antibiotic of choice. Fluorophenocal isn't commonly used on these bacterial culture and sensitivities. They use chloramphenicol, which fluorophenocal is a derivative, so they're very, very close in terms of the mechanism of action. So we knew that the bacteria here was susceptible to the chloramphenicol. Chloramphenicol as an injectable is 1, incredibly hard to obtain, 2, incredibly expensive, and 3, not really used anymore because there are better alternatives. So fluorophenocal being a easier to obtain, less side effects, we jumped with the fluorophenocal on the basis that it's the same mechanism of action as chloramphenicol. So we had injections. It started to clear up relatively quickly, but then we had some of these like lingering lesions. So we actually switched from intramuscular injections to intra-abscess. So I was actually sedating the fish and injecting the antibiotic directly into the abscess. Because what happens with an abscess is you have a bacterial infection, the body tries to protect itself and walls it off. By walling it off, it prevents the bacteria from spreading to the rest of the body, but it prevents the immune system and blood supply getting into the abscess. If we stop blood supply, we stop the immune system. We're using a bacteriostatic drug, so the bacteria is not growing, but if the immune system's not getting there, then it's not going to clear that bacterial infection. So that's why I started injecting it intra-abscess, as well as using meloxicam, which is a non-steroidal anti-inflammatory medication. Many of you may have used it if you've, like torn your shoulder or some, gym pain. Again, it's a phenomenal anti-inflammatory. So I wanted to reduce some of that inflammation to increase blood supply to allow the immune system to be able to get into these lesions and clear them. Otherwise, she would have needed to be sedated, and those would have been surgically removed.
Yeah, so we actually upgraded the pond for very high-end koi fish, and you can see that being done here. And this is winter time as we start to drape things and close it down, and we keep some pretty high-end koi in there, and Baki showers, rotary drum filters. And here is, well, we don't have sound, but here is a trip to Vegas where we brought fish, and I just found that I won. And that's the best koi in the United States right there, belongs to me. And we won several awards that night. And those were the koi that won awards. In the meantime, we are upgrading another pond right now because we need more bodies of water. We definitely need a quarantine system or a system for championship fish. So that is being built right at this second. And we look at, this is actually something else I'm very proud of. Sunrise Day School was over, and we're going to be in 213 hospitals with them under cancer chemotherapy, doing videos for them and making their children feel special and relaxed.
So here I'm just swabbing one of Andrew's koi for bacterial lesions. It's an external lesion, so we have to be careful with the way that we interpret those bacteriological reports. We already know the fish has Aeromonas, but I just want to see if there's any secondary infections because she wasn't doing well, so she was staying at the bottom of the pond for a while. And by staying at the bottom of the pond, she was getting pressure sores on the pectoral and pelvic fins. So we wanted to make sure that there wasn't a secondary bacterial infection going on there, and that's what the swabbing was there. In terms of making sure that the lesions are sterile and that we're in a goal to swab the bacteria of concern, we take sterile water and actually rinse the lesion first, because if it's coming from the fish and seeping out of the lesion, then it'll continue to do so. If it was just on the surface and we rinsed it off, then the likelihood of a commensal bacteria being cultured is dramatically less.
This is pond 2 now getting upgraded. And you'll see a lot more. There you go. It's really, other than decorating the wall and with bluestone, which was already on, but we took off, and figuring out what goes on the wall. This pond is almost done. And these are the ponds that we have in plan in the backyard in addition. Probably may not need 2 if I have 2 in front, but it really is nice having 3 ponds. You could put your championships in one. You use one for quarantine or getting ready for a show, and then other ones for not as high a quality. More ongoing projects at Polo Reef. This was a 200-gallon cube that was next to the big display tank at the bar. It had some deep water Anthias and deep water Abai Angels. Everybody loved this tank. The problem was it didn't fit the size proportion relative to the 17,000. So we brought in, it's now in the lab, and what we did was bring in top shelf to
That's a 25. This is the 900.
oh yeah, this is 900. All right, yeah, this is the 900-gallon tank, which is being replaced with that 25-gallon cube. This took a year. Came in cracked first. L-shaped tanks are not easy. They can't leave their stand. They need to be craned over houses and so forth. They're not good being delivered because any bump is basically a potential glass break. And this is what the tank pretty much looks now. We added a school of purple Anthias. Got a couple of special koi tangs in there. And set this tank up rather quickly. I'd say and then you have Michelle here who's doing a wall of chalice in the tank, gluing, there you see it right there. And she glued all that chalice together, and you'll see the purple queens. They made it through quarantine. And we feed this tank 7, 8, 9 times a day because of our small Anthias and the purple queens.
I think that's critical in keeping them. They're grazing fish, and feeding them 1 meal a day isn't gonna give them the nutrients that they need. So yeah, we've bumped it up to 7 times a day.
Yeah, it's basically anytime someone goes by, grab some food and squirt.
Does that one go to the same sump, or does it have its own sump?
This, it has its own sump, but it's connected to the 150 anemone tank above us. But it's a different system. And this is the 2500, which is our next project. The only thing that has to be done here is cabinets. Now, this project was brought in with, or that's what it looks like now, brought in Australian reef rock. The guys over at Top Shelf built a model around our closed loop so we wouldn't see any pipe, and made this for us after many glue, accelerate. We wanted something different. We wanted it a little bit more open, a little bit more lagoony. This tank is 12 feet wide, 6 feet deep, 4 feet down. And it is being run on a rotary drum filter. There you go, right there. No socks. We learned this from the koi industry. And the water just goes right down, that's our water going right down in Fred's drain. So it cleans itself. And there's sand in there. It is cycled. It is ready to go as soon as Alex is ready to release me some fish. There's the closed loop on it. It's pretty powerful closed loop.
These pipes are not big enough.
And this is the MRC skimmer that we have run on it, and that's what she looks like right now without coral. I assume, and we do have sand in there, so the fish, and we're using ammonium bicarbonate right now to keep it stable. So as we add fish, we'll drop the bicarbonate. And that's the back of the tank. And we're using Orphic Amazonas, 6 of them. 1, 2, 3, 4, 5, 6, along with 2 radium halides. Sea swirls. And that project will have life in it within 2 weeks. So that sort of takes us through what we've been doing. We have 3 cubes up right now. We have 3 more to go. We'll be doing more experiments in medicine. We'll be doing more lighting experiments. We're trying other people's lights. We have, I don't know, 3 or 4 lights right now that we're working on, waiting to see how the corals do. And they'll be on YouTube's, and we'll have guests on pods and papers written.
So we're working on a couple projects that we'd like to have published in some peer-reviewed journals moving forward. First helping the hobby, and then having written protocol and definitive treatments for very definitive disease rather than the guesswork that is previously done. Again, I'd really like to stray away from, you see a lesion, let's just dump a random drug in without knowing what the lesion is, without knowing the mechanism of action of the drug, without knowing if you're using the medication even appropriately. So that just makes things a lot more difficult in the long run. So the big thing that we're pushing is identifying disease and using specific treatments for those diseases.
Have you thought about bringing in microbial genetics in-house, given the amount of work you guys are doing for culturing and the time that it takes to culture, and the fact that many of these things just can't be cultured at all?
Yeah, so culture is incredibly difficult. We've had instances like with mycobacteria, it takes 8 weeks plus for you to say that that's a negative culture. So in DNA, DNA would be nice. We don't have the capability in-house. That's why we've reached out to University of Florida. There's a pathologist down there that we're working closely with. And one of his interests is new age gen sequencing. So that's what we'd like to do moving forward. Again, overnight it down there and have him start working on the next day. That's where we'd like to start moving, but potentially working with Aquabiomics and their panels. It's really important finding someone who has the panel. Sequencing the DNA is complex but doable. It's, do you have a database to go, this is what we're looking at? Because otherwise it's just a bunch of letters. So having someone who has a definitive database makes a big deal. And that's why we're interested in Aquabiomics, is he spent a lot of time characterizing Vibrio. So we really like that. Okay, we can find, we know that if we send out samples, we're going to potentially find Vibrio. That's a given. But is it the Vibrio that I see causing disease? So again, it's who has that database. And right now, if we started our own in-house, none of these labs are going to share their database with us because now we're a competitor. And again, that's their safeguarded information. So they wouldn't, again, tend to share that information. So right now, we're just...
You provide database access for bioinformatics support as a fee-for-service thing, though. So you could potentially just outsource the computation, which would be...
Yeah.
Waiting for things to go through Aquabiomics, they're doing batches
Well, yeah, so that's why we've been in talks with them about, having results within 3 days or so. So it's still long.
In terms of what could be done.
Yeah, absolutely. Well, yeah, that's why we're experimenting, and if that doesn't give us the results that we need, UF is willing to have those results super fast for us.
Doing the experiment is relatively straightforward. it's gotten to the point where next-gen sequencing, using the machines that they use for these types of things, is more like running a microwave than.
Oh yeah, absolutely.
Yeah, he just has to open up his emails and he'd go to his post office. They're introducing pebble rock now, you know, with bacteria. Do you see
I
that?
think it's cool. I think it's cool.
I just think it's distracted them a little.
Fair enough.
But that's why we've workings with UF on the back burner, and we're working with them on some other projects as well, and hopefully have some pretty interesting results in the next coming months.
I gotta go.
Okay.
So